Hello viewers, we can see one topic from the 5th unit of Theory of Computation. The topic is Recursively Enumerable Languages. The objectives are to understand the properties of recursively enumerable languages. First of all, what is meant by recursively enumerable? It is shortly called as RE languages. Recursive enumerable or type RE languages. It is otherwise called as type 0 languages or generated by type accepted or recognized by the Turing machine, which means the Turing machine will enter into the final state for the string of language or may not enter into rejecting state for the string of language. So such kind of languages are called as recursively enumerable languages. It means Turing machine can loop forever for strings which are not languages, which are not acceptable by the given Turing machine, are called Turing recognizable languages. Now we can see what is meant by recursive language. A recursive language can be decided by Turing machine. That means while after processing with the particular string, the Turing machine can tell the conclusion about whether the string is acceptable or not. So such languages are called decidable languages by the Turing machine. Okay, so languages which can be decidable by the Turing machine about its acceptability is called decidable languages. All the decidable languages are recursive languages. For example, L equal to A power n, B power n, C power n is recursive. We can construct which is acceptable by Turing machine. That is, we can construct a Turing machine which will move to final state if the string is of the form A power n, B power n, C power n. Then the concept of the Turing machine is the acceptability will be decided by two cases. One important case is when the system reaches to the empty stack. We can say the system, the particular string is acceptable. So the languages in these kinds like A power n, B power n, C power n. So similar same number of input symbols of the different category can be acceptable by the Turing machine. So the recursive languages are otherwise called as Turing decidable languages. So we can see in this diagram, we can see all the recursive languages are recursively enumerable languages. Now we can see the closure properties of recursive languages. First one is union. If L1 and L2 are two recursive languages, then their union L1 union L2 will also be recursive, because if the Turing machine halts for L1 and halts for L2, then the Turing machine will also halt for L1 union L2. Then concatenation. If L1 and L2 are two recursive languages, their concatenation L1 dot L2 will also be recursive. For example, if L equal to A power n, B power n, C power n, if L2 is equal to D power m, E power m, F power m, then L3 will becomes L1 dot L2 will have the resultant language of the form A power n, B power n, C power n, D power m, E power m, F power m will also be recursive. Then lean closure. If L1 is recursive, then its lean closure L1 star will also be recursive. For example, L1 equal to A power n, B power n, C power n, then L1 star, its lean closure language, resultant language will be written as A power n, B power n, C power n, the whole power star will also be recursive. Now intersection and complement. If L1 and L2 are two recursive languages, their intersection L1 intersection L2 will also be recursive. For example, L1 is one language pattern and L2 is one language pattern. L3 is the intersection of both languages. That is L1 intersection L2. Now the resultant language will be of the format a power n, b power n, c power n, d power n. The resultant language will have the same format of the second language L2. So the resultant language will also be recursive. Now similarly, the complement of the recursive language, that is, complement means if the language is L1, we can say the complement of the language is dash L1. So the complement of if the language is recursive, the complement of the given language will also be recursive. So these are all the properties of recursive languages. And we can have the question from this topic: state the properties of recursively enumerable languages. Thank you all.